All right, number 9. The velocity of an object after t seconds is given by v of t equals 15 square root of t minus 3t when time is between when time is between 0 and 25 seconds. On the grid below, sketch the graph of v, clearly indicating the maximum point. All right, so we got to indicate the maximum point, and we're going to sketch the graph of v below. This is a calculator question, and whenever you see something that's like obviously not going to be easy to create on your own, you should definitely type it into the calculator. So go ahead and type it into the calculator. And then you can use graph trace to get some points. Okay, let's see where we're starting with this guy. Okay, oops. So he's going to start at 0, 0. And then he's going up to 113. 1, 2, 3, 4, 5. All right, we're counting by ones. Right, and then actually this interval goes all the way to 25, so I'm just going to pick the nice points. 317. I'm going to probably skip a few in a few minutes. All right, let's get a little further on down the line. Ooh, the maximum is 6.25, 18.8. Okay, so 6.25, 18.8. So that should be right around like there. Let's clearly label it like they told us to. Right, and then a few points to the right of that. How about 918? 918. Oops. 918. And then 1612. Nothing else is too great here. Okay, well, we can approximate 5.75. That's fine. 21, 5.75. And then 25 is 0. Okay. So let's, oops. What am I labeling this as? V of t equals 15 square root of t minus 3t. All right, cool. 9b says, let d be the distance traveled in the first 9 seconds. I write down an expression for d. 2, hence write down the value of d. So we're going to use whatever we got in part 1. That's what the hence means to answer part 2, okay? So write down an expression for d. D is the distance traveled in the first 9 seconds. So we know that distance traveled is the integral of the velocity, and it is its absolute value, and it's in the first 9 seconds. So it's going from 0 to 9. So let's go ahead and put in, we have to write down a full expression. So let's go ahead and put in the things that they gave us from above. 15 square root of t minus 3t. And it just so happens that this whole item is located above the x-axis. It's all positive areas. So we don't really need the absolute value bars anymore. You can leave them in. It certainly wouldn't be marked wrong anymore. But I want us to start thinking critically about these types of problems. So if it's all positive, we can just leave it off at this stage in the game. So that's our expression. And then now let's do the value of d. Oh, calculate the value of d. Okay, so we would integrate this guy, and that would become 10t to the 3 over 2 minus 3 over 2t squared. We're going from 0 to 9. And then, of course, type this in your calculator at the end to make sure that we're right. And you would get 148.5. meters. Let's make sure we're right. When you're typing it in your calculator, oh, what just happened there? An integral and an integral, I don't want that. You can use the absolute value bars or not. You should get the same answer because it's all positive area in this problem. Minus 3x dx. Get in there. There we go. Okay. 148.5. Bada boom. Okay, and then just to show you that it doesn't matter if you put the absolute value bars or not, if the whole area is located above the x-axis, let's enter that whole guy again, but remove the absolute value bars now. Boom, same thing. Thanks for